Okay guys, what we're looking at here is the underside of a Manticore Mantra, which was quite a popular turntable in the 80s, or was it the early 90s, I can't remember. It was sort of a competitor for a Lin Sondek at the time, a Lin LP12. It was about 100 quid cheaper, so it was sort of the deck to have in between the planar 3 Rega and the Lin. So let's have a look at the motor setup as standard. As you can see, we've got a wire coming in from the mains for 240 volts, going to the stop and start switch, the on and off button there. And then we've got a little plastic housing here, clear plastic housing, to keep people safe from electric shocks. And in there you can see the capacitor. Now that is, you've got your 50 Hz sine wave coming in from the mains, and one of the phases from the motor will be going through that capacitor, which will slow the sine wave down and which will create a cosine wave, and the sine wave will just come from the normal output from the mains. It won't go through a capacitor, so that will be your two phases to drive your motor. You can also see quite a big resistor there, and that's because this is a UK turntable, so 240 volts. If we have a look at the motor, yep, we've got 110 volts, so that's just to step the voltage down to 110 volts for the motor. Okay, so I'll stop now, and then I'll rejig the wiring inside and show you what I've done, and then connect it up to the variable frequency drive. Okay. Right, I've removed the cover off the little electronics box that's inside the turntable, just so you can see this a bit more clearly. We've got two grey wires coming from the motor. They go to neutral. As you can see, we've got the neutral wire coming from the mains, and then that's going through the white wire. But basically the two grey wires, they'd be going to the neutral wire coming from the mains normally. What we're going to do is I'm going to wire those up to basically and then I'm going to reuse this wiring and wire it into the variable frequency drive. We've got two other wires coming out the motor. We've got a red wire and we've got a blue wire. Now the blue wire is going through the capacitor, so we'll be connecting that up to the cosine output from the drive, and the red one, that will be going to our sine output. So we'll leave that board in place, but I'll desolder the wires and reconnect them and put a new plug on the end of the cable, so we can connect it up to the drive box, and then we can have a play and see how well it works. Right, I've rejigged the wiring now, so we've got two grey ground wires coming out the motor. That's actually going to ground or earth. Now remember, this isn't getting plugged into the mains now. This is wired up for use with the variable frequency drive only. I've retained the on-off switch. Hopefully it's not got a neon in it. I don't think it has. If it's not got a neon in it, it's just a normal switch. We can keep that in place and still use that to start and stop the turntable, even through the variable frequency drive, although that has got a motor start and stop switch on it. I've just soldered those wires, put some heat shrink on them and soldered them onto the live and neutral. If you don't like using a soldering iron, as a lot of people don't, you could have just stripped those wires and used one of the just a little block connector that's supplied with the drive kit. Okay. Right. Next step. Put the plug on it to connect it to the drive, and let's spin it up and see what we've got. Right, so there's the variable frequency drive output plug, which has replaced our mains plug. So it should be right. It's the first test. I've got the belt on the small pulley coming from the motor, so that'll be the 33 RPM setting normally. It has got a neon in the on and off switch, but it's not a problem because the V.F.D, the variable frequency drive, powers it once the hertz gets up. It doesn't make any difference to the operation anyway. It just doesn't come on at very low frequencies like this. This is about 17 hertz, and you can see how slowly the subplatter there is turning. Now if I increase the frequency, you can see what happens. Gradually increasing now. Got really good control over the speed. You can see the speed's picking up now until we're belting along. Now the thing with these motors is your mileage tends to vary a bit with them, because some will operate at higher frequencies than others. This one seems quite good, and it's probably still operating, I'd say, at about 80 hertz there, maybe more, so we're really spinning there. So, but once you go sort of beyond the limits of the motor, it stops spinning and you'll just hear a noise come out of it. You can hear the frequency there. You can see the neon even switching off in the on-off switch when the frequency gets too high. It doesn't damage the motor, it just won't spin at the those very high frequencies. Well, not very high, but high frequencies for this type of motor. So with this motor, I'd say we could have a speed range from 78 RPM down to 16 RPM, no problem at all, because it looks like we're even getting about that on the smaller pulley. If we put it on the larger pulley, the 45 RPM pulley, should give us even more speed per frequency. We've got basically any speed we want with this turntable now. Have a look at the drive there. And obviously, yeah, got the on-off switch. That'll stop it. I do think that neon might be interfering a bit with things.